Hello friends, welcome you again in the course of Fundamental of Engineering Physics, and today I am going to discuss on the topic of photovoltaic cell. In this lecture we are going to discuss about this the photovoltaic cell, which is actually based on the quantum theory of light and especially used in the explanation of photoelectric effect. So, before going to the details of this photovoltaic cell, we will briefly discuss on that the quantum theory of light, and then overview of photoelectric effect, and then the Einstein's equation of photoelectric effect, which will help to understand the phenomena in detail of this photovoltaic cell, and then the photocells, its introduction and the classification, and then I will try to make some details of this photoemissive cell and the photovoltaic cells and comparison between these two, and finally, we will conclude this lecture. So, objectives of this lecture is to give an overview on photoelectric effect and to impart knowledge on quantum theory of light and Einstein's equation to explain that photoelectric effect, and to introduce that devices based on this photoelectric effect, that was photocells and its a classification in terms of this photoemissive cell and photovoltaic cells, and then to discuss about this photoemissive cells and the photovoltaic cells in detail with the comparison. After attending this lecture, you will be enabled to understand the basic concepts of quantum theory of light and its applications in form of that photoelectric effect, and also you will be able to apply this photoelectric effect in the photocells applications especially, and you will able to learn some fundamentals mathematical formula to solve properties of photocells technology. So, first of all, let us overview on this photoelectric effect in one of the lecture that was dedicated to this particular topic, that photoelectric effect. So, what we know that the ejection of electrons from a metal plate when illuminated by light in of the suitable wavelength or the frequency, it is called photoelectric effect, and these electrons which is emitting through this falling of that light, it known as that photoelectrons, and the corresponding currents generated through this flow of this electron, it is known as photocurrent, and the materials related to this phenomena, that is known as photosensitive materials. And we have some examples of such materials, that is if you consider that metals, then CD, Z and Mg, these are showing photoelectric emission with that ultraviolet light, and some alkali metals like lithium, sodium, cesium, this respond well even to visible light. So, some properties of this photoelectric effect: in the metallic surface, the emission of photoelectrons takes place only if the frequency of light is greater than a certain minimum frequency called the threshold frequency. For a frequency above this threshold frequency, the numbers of photoelectrons emitted is directly proportional to the intensity of light. As intensity of light increases, the number of electrons emitted that will be increases. The saturation current is also directly proportional to the intensity of light. The maximum kinetic energy of the photoelectrons, it is independent of intensity of light, it does not depend, and but this is actually the function of the potential difference between that electrodes, and the maximum kinetic energy of the photoelectrons from the given metal is, it is directly proportional to the frequency of incident light. And one thing, that is there is no time lag between incident of light and the ejection of photoelectrons. Once photoelectric phenomena has been thoroughly examined, the attempt was made to explain on the basis of the wave theory, but it was failed, and then that Einstein's theory, Einstein's equation, on the basis of that Planck's concept of light, it was used to explain this phenomena. So, let us have some glimpse of that quantum theory of light also. We should know about this, just going through that overview in the chart. So, the after Max Carnot, Ernst Ludwig Planck, we know about this light. It is the earlier known as electromagnetic wave, which is propagated a small energy packets as per the proposal given by Max Planck, and this packet which is named as quanta, and after some time it is also known as photon, it is quantized and its energy, it is proportional to that frequency. So, we have this E is equivalent to h nu, where h is a Planck constant. So, this is that special type of packet which is a vibrating packet, and we also know that light behaves both as a wave as well as a particle. We have proved that light has wavelength and frequency along with its mass and momentum, but this dual nature it does not come at the single phenomena. Then we also know about this Einstein's equation to explain this photoelectric behavior. So, that is equal to h nu, this is that energy of incident photon, it is equivalent to phi naught, which is the work function of that particular metal. So, this is that minimum energy which is required to emit peek out that electrons from metal surface, plus that half mv square, this is that kinetic energy of that electron. And in this process, a part of the photon energy, it is used in overcome to the potential barrier of the metal surface, and the remaining energy, these are as the kinetic energy of the ejected electrons. And this is from whatever this equation we have written, this is from the law of conservation of energy. So, whatever energy it is given to that metal surface in form of a photon, and it is purely completely used by that electron. First part is to overcome that surface barrier, and the second part to gain kinetic energy. And one thing here I would like to mention that one photon, there is one to one mapping, the energy of one photon is completely used by that one single electron, it is not distributed to a group of electrons. So, the explanation in text we can say that as each incident photons liberates one electron, then the increase of intensity of light increases the numbers of electrons emitted, thereby increases the photocurrent. The same has been experimentally observed. So, we have different curves of that for related to that photocurrent in terms of frequency, in terms of intensity, as well as that stopping potential, and these are that the summary of that whatever we have observed. So, from K max is equivalent to h nu minus phi naught, it is evident that this K maximum, the kinetic energy of that electron, it is proportional to the frequency of incident light, and it is independent of intensity of light. This is the observation. There must be minimum energy for incident photon to liberate electrons from the metal surface. Below the value of this energy emission of electron, it is not possible. Corresponding, there exists minimum frequency called threshold frequency, below which there is no photoelectric emission. According to quantum concepts, the transfer of photon energy to the electron is one instantaneous phenomena. So, there is no time lag between incident of photons and the ejection of electrons. So, when we just if you want to know the details, or we want to feel that material what is happening after incident of that photon on that metal surface, just I am giving some numerical calculation values here. So, let us assume that when light of wavelength 2200 angstrom, if it is fall on copper photo emission, or for photo emission it is emissions from it, and let that threshold wavelength of and that stopping potential we can calculate if that work function of this copper is given as phi naught is equivalent to 4.65. So, we have given that wavelength of incident wave in form of photons on that copper surface, and also given this work function of that metal surface, and we can easily calculate this threshold wavelength as well as that stopping potential. So, we have this formula. So, that phi is equivalent to h nu, and one can write this h lambda in terms of lambda, that phi is equivalent to h c by lambda nu. So, we can calculate this threshold wavelength, that lambda nu is equivalent to h c by phi naught, and by putting the value of this Planck constant as well as this the speed of light, that is 3 into 10 to the power 8 meter per second, and this work function, that work function is given in electron volt. So, we will convert in joule. So, that is 4.65 into 1.6 into 10 to the power minus 19, and then after calculating that we can get that lambda naught is equivalent to 2672 angstrom. and also we can calculate that energy is equivalent to hc by lambda. So, by putting that constant value h and c and lambda, that is the wavelength of incident light, that is 2200 angstrom. So, again we will convert that angstrom in meter, and then we can get this energy in terms of joule, that is 9.035 into 10 to the minus 29 joule, and one can convert this is equivalent to 5.65 electron volt. And then finally, we can calculate this kinetic energy K max is equivalent to h nu minus phi naught. So, here this the energy we have calculated is equivalent to 5.65 minus 4.65. So, that kinetic energy in maximum, that is equivalent to 1 electron volt. And also we can calculate this that stopping potential. So, this kinetic energy is equivalent to E multiplied by V naught. So, by putting this value we can calculate that stopping potential too, and obviously that will be 1 volt. So, the some applications we should discuss, because we are now in the application part of that photoelectric effect, especially for that photovoltaic. So, we can also discuss about some more applications. So, the first one is that solar panel. This is the one of the known application of that photoelectric effect. The solar panel actually converts light energy into electricity with the help of a photoelectric effect. When the photons of sunlight falls on the semiconductor installed on the solar panel, they displaces the electrons from their atoms, and the moment of electron causes generate electricity. So, here that maximum these solar panels or solar cell, these are semiconducting based device which converts that light energy into electrical energy. And then the second application we can discuss as the light sensor. So, the photo cells are used in a light sensor. When light falls on the photo cells, it creates electric energy which can be used to trigger various switches like automatic light on off systems. So, this is one of the application of that photoelectric effect. Then digital cameras also used this phenomena. So, CMOS, the complementary metal oxide semiconductor, or CCD, charged coupled device, these are semiconductor based device. Sensor is used in digital camera which uses the principles of photoelectric effect, and they convert electrical signals are used to create digital image. So, that photoelectric effect actually used to convert that that light energy into that electrical, and that converted electrical signal, these are used to create a digital image. And then barcode scanners, the photodiodes are used in the scanner when it is placed on the barcode intensity of the light channel charges, and photoelectric effect is used to convert this light into digital, which can be used to identify the product. Smoke detector, the photoelectric effect can also be used in smoke detector. Light source and the photosensitive sensors are used in the smoke detector to detect the fire. When smoke enter inside the case of sensor, it scattered light on the sensor which triggered the alarm and started sprinkling water. And security system, the security system uses photoelectric sensor to detect the motion of an object. It works by emitting light rays and measure its reflection. Changes in the intensity of the reflected light indicate the motion of the object. So, this is that one of the best application of this photoelectric effect, that is in security system. So, these are that different applications in our daily life, and some advanced level applications in medical science and the research purpose. So, that X-ray photoelectron spectroscopy. So, the photoelectron spectroscopy involves irradiating a surface with X-rays and measuring the kinetic energy of the electrons that are released. It is used to learn important features of the surface chemistry, such as element composite, chemical compositions, the empirical formula of compounds and the chemical state. This can be acquired. So, that composition analysis, chemical composition of analysis, this can be actually detected by this special technique that is known as XPS in field of research, material research. And also in the medical field, X-ray imaging, the photoelectric effect is utilizing in X-ray imaging systems to produce high resolution image of the human body. when X-rays are directed at the patient's body, some of the X-ray photons undergo the photoelectric effect, leading to the absorption of X-ray photons by the body tissues. X-rays imaging is commonly used for diagnosing fractures, detecting tumors and examining internal organs. So, this is the important application of this photoelectric effect. CT scan, that is known as computed tomography scan. CT scan utilize the photoelectric effect to create detailed cross section images of the body. It is in CT scanning, X-ray beams are directed at the patient's body from multiple angles, and detectors measure the intensity of the X-ray photon that passes through the body. And CT scans are used for diagnosing conditions such as tumors, trauma and vascular diseases. So, this is also one of the good example of photoelectric effect. Okay, so let us come to the our main point, that is the application of this photoelectric effect in optical device, that is in photovoltaic cell. So, first of all we should define this photo cell. So, this photoelectric cells or photo cells, it is a device which converts light energy into electrical energy. It works on the principle of photoelectric effect, and when light is incident on the photosensitive material, their electric properties will get affected, based on which photo cells are these photo cells are classified into three types. So, we have three types of these photo cells. One is photoemissive cell, second one is photovoltaic cell, and third one is that photoconductive cell. So, these are three different types of photo cells. So, out of these three, we are having this photovoltaic cell in the second part. So, first let us discuss about this photoemissive cell. Its working depends on the electron emission from the metal electrode due to the irradiation of light or other radiation. So, photovoltaic cell, the second one, that is here this sensitive elements made of especially that semiconductor, it is used, which generates voltage proportional to the intensity of light or other radiation. And the third one is that is photoconductive. So, these are the short description of those three devices. So, that photoconductive cell, in this the resistance of the semiconductor changes in accordance with the radiation energetic incident on that. So, in the first case, that in photoemissive cell, that the emission of electron it takes place when that light irradiate on the surface, and second one that that is converted in form of that intensity of light that converts in the form of volts, and in the third case we have this the change in the resistance and resistance one can observe with the effect of that light. So, these are the data difference between these three photoemissive devices. So, this is the photovoltaic cell, and here one schematic diagram of this photoemissive cell is seen. So, it consists of an evacuated glass or quartz bulb in which two metallic electrodes, obviously that one will be cathode and second one will be anode. These are fixed at a specific distance, that is shown in the figure, and the cathode C, it is represented by C, is semi cylindrical in the shape, and it coated with the photosensitive materials, because all that electrode materials are not photosensitive. So, that coating type phenomena it is occurred for to fabricate this cathode material, which can easily emit that electron. So, second, the anode A is the thin rod or the wire kept along the axis of the semi cylindrical cathode. So, that is that cathode is cylindrical, semi cylindrical, and that anode is at the in form of that wire that is at the center of that semicircle. A potential difference is applied between this anode and the cathode through the galvanometer G. When cathode is irradiated with suitable radiation, electrons are emitted from it. These electrons are attracted by anode, and hence a current is produced, which is measured by the galvanometer. For a given cathode, the magnitude of current, it actually depends on these two parameters. First, that intensity of light incident on that cathode, and the potential difference between anode and cathode. And then this applications of this photoemissive cell, that is photo cells have many applications, and obviously some will be a mimic of that the earlier application we have discussed, especially as switches and sensors, automatic lights that turn on when the gate dark use photo cells, and street lights that can switch on, and these are the examples of our daily life, switch on and off system according to whether it is night or day use that photo cell. So, automatic light system, that street light, this cell is used, and then photo cells, these are also used for reproduction of sound in the motion picture, and are used as a timer to measure the speed of athlete during a race, and the photo cells of exposure meters are used to measure the intensity of light and to calculate the exact time of exposure. Now, the photovoltaic cell, this is the second important optical device based on this photoelectric effect. So, this photovoltaic cell, it consists of 2 or more layers of semiconductors, which one layer containing positive charge and other negative charge linked adjacent to each other. So, this is one layered structure device. So, there is a difference in the that first device with the second. In the first device we have that electrode and cathode separately, but here that is made up of semiconductor, special type of semiconductors, and that structures are in the layered structures, and that layer may be 2 or more than 2 more structures. And this sunlight consists of small packets of energy, obviously that photonic light strikes the cell where it is either reflected, transmitted or absorbed. So, these are the simple the phenomena of the incident of light. This can be either reflected, transmitted or absorbed. When the photons are absorbed by the negative layers of the PV cell, that photovoltaic cell, and the energy of the photon get transferred to an electron in an atom of the cell. So, that energy transfer from photon to that electron, it is taking place here. When the increase in the energy, the electron escape the outer shell of the atom, and the free electrons naturally migrate to the positive layer coating, creating a potential difference between the positive and the negative layers. So, the one potential difference is created due to that transformation of electron from that negative layer to that positive layer. When this the 2 layers are connected to the external circuit, the electron flows through the circuit, and this creates current. So, this is that the schematic diagram of this photovoltaic cell, and here that one panel is here what that panel is looking like, and that one layer of panel, and the second that material, it is can be designed in a special shape depending on that application, and that fabrication of this type of device, it is one of the good research in the field of this optoelectronic. This is known as optoelectronic devices, where optical energy is used for that electronic on the electronic materials to create that current. So, this is that diagram, and here that sunlight incident is shown, and that to check that emission phenomena, one bulb is used. So, this advantage of photovoltaic cell. So, in this is environmental susceptibility, this is one of the advantage. This photovoltaic cells generates clean and green energy as no harmful gases such as carbon monoxide, carbon dioxide, nitrogen monoxide, nitrogen dioxide, trioxide type. These are not emitted through this. So, these are environment friendly device. Also, they produces no noise pollution, which makes them ideal for the application in residential area. So, that environment friendly device this is, and this is one economical viable, because the operation and the maintenance cost of these cells are very low, because this is semiconductor based device. And one thing is good in this semiconductor technology is that the semiconductors, these are cheap with cheaper with compared to that metallic or other type of devices. And also that cost of this solar panel is made up of this photovoltaic cells, these are incurred in only the initial cost. So, we just you have some initial cost for purchasing as well as installation, and there is a very minimum maintenance charges there, and this is that is why this is cheaper with compared to other optoelectronic devices, optical devices, and accessible. So, solar panels are easy to set up and can be made accessible in remote locations or sparsely inhabited area as the laser cost are compared to conventional transmission lines. So, if we want to use that transmission lines, so that will be costly, as well as at the remote area it is not possible to reach with this transmission line. So, this is one of the best application of this photoelectric effect, where we can use this as in form of that solar panel at the remote areas, and we can generate that electricity. So, they are easy to install, installation is not very complicated, and without any interference with the residential lifestyle. So, since it is environmental friendly, so it is anywhere one can install there, and nowadays in the different villages in India also we can have this type of photo cell based these panels on the street as well as on the rooftop of our homes. Renewable, so energy is free because it is coming from that light, and obviously if we are using that sunlight, so it is free, and abundant in nature because it is a sunlight, it is abundant in nature, and we know that that conversion of that energy from sun to this, and the cost is also good because the solar panel they have no mechanically moving part except its some highly advanced sunlight tracking mechanical basis. If we are using just a common solar panel or a solar system, so there is no moving part, but if you want to use some advanced type of solar cell which actually track that the motion of the sun, and it change its position with time to time. So, that may take some cost, but in general it is very cheap. Some disadvantages are also there because the efficiency of solar panel is low compared to other renewable sources of energy. So, that whatever that energy it is given to, it is not converted to that electrical energy. So, energy from the sun is intermittent and unpredictable and can only be harnessed in the presence of sunlight. Also, the power generated gets reduced during cloudy weather. So, if there is some cloud and that weather is not good, then this may create some problem. So, at that time if we have that energy saved, then we can use, otherwise that at that time that solar panel let us say useless, and the efficiency it is really very less at present whatever that solar panel available in the market. Long range transmission of solar energy is insufficient and difficult to carry. The current produced in DC in nature and the conversion of DC current to AC current involved in the use of additional equipment such as inverter. Actually that converter, that photocell actually creates that DC cell, and in our household applications we use AC, alternate current. So, we have to convert this DC to AC. So, the conversion of this AC, DC to AC, so some inverters are used, and it take some cost. And these photovoltaic panels, these are fragile and can be damaged relatively easily, and additional insurance costs are required to ensure the safeguard of the investments. So, these are some drawbacks or disadvantages of this photovoltaic cell also, and the people are trying to overcome all these disadvantages and try to get some good solar panels or photovoltaic cells. The role of these photovoltaic cells, to begin we shall first examine the role of photovoltaic cells in our solar photovoltaic system, and this solar cells produces electricity via the photovoltaic effect, and where the sunlight creates electricity in certain material by knocking their outer electrons loose, and without getting too technical, because that technicality is very lengthy and complex. Here just I am giving that glimpse and that overview. So, the photovoltaic cells can be made from either monocrystalline materials or it is polycrystalline materials, and this consists of several layers. So, in that structure I have also shown that it is layered materials, and the more most important of which are these two semiconductors in the center. And the top semiconductor is a negative layer, as the material atoms contains extra electrons which carry that negative charge, and in contrast the bottom semiconductor is positive layers, as the materials atoms have missing electrons. So, we may have different layers of semiconductors, and the center two layers of semiconductor, these are used as that negative and positive layered semiconductor. So, when sunlight hits the top semiconductor, the loose electrons become excited and knock loose, and then attracted to the positive layer beneath, and the barrier between the two layers is formed as a conductor, or both layers force the electrons to travel around the cell, creating the electric current, and the conductors then force this current out of the cell and into an electrical load which captures the energy photovoltaic cells has produced, and the electrons eventually recenter the cell, and process repeats. So, because photovoltaic cell only generates the limited amount of energy, numerous cells are connected to create the solar panel. So, the solar panel is actually the combination of so many photovoltaic cells, and these are the working together. Multiple solar cells generate higher currents and therefore more energy. In addition, by sealing multiple cells together, panel acts as the photoactive cases for the cells of the existing. So, in addition, by sealing multiple cells together, panel act as a protective case for the cells to exist in. This means the solar cells are less susceptible to damage by external factors, including severe weather such as hail. Okay. So, as a summary, we can say this is the one of the best application of this photoelectric effect, and to understand this particular photoelectric effect, we should have the knowledge of the basics of that photoelectric effect and its application, and also if you want to know that photoelectric effect in detail, then its the explanation, its experimental verification, and also although I have given this in a separate lecture, but to understand this particular device we should know about that. That is why I have included this as a brief part of this, and that photovoltaic cells, these are really that demand of the future, because it actually creates that solar energy, that sunlight energy to that electrical energy. One thing that is a big challenge for the future is its efficiency. Thank you all.